Alright, fine. Hello, and welcome back to the FTC CADing tutorial. Last time we covered how to import files into Fusion through revrobotics.com. This time we're going to focus on CADing the basic frame of a drivetrain. To do this, we will use joints and mirroring techniques. But the first thing we need to do is create the file where our drivetrain will be made. So it's important to name this file, otherwise you won't be able to edit it. So I'm just going to call it Drivetrain, and it is automatically saved in the folder we created last time. Now the first step is to import files necessary for the drivetrain. So the first file we're going to import is our 420 millimeter long extrusion. Its ID number is Rev411432. To import it into this design, simply right-click on it and select Insert into Current Design. You can see we now have the extrusion here, but don't click OK right away. We need to make sure it's in the correct orientation. Since this will be the backbone of our drivetrain, this should be at a 90-degree angle, and do not move it in the X or Y axes, as it should be aligned perfectly with the Y axis, and we'll get into that later on. Once it's rotated, you can click OK. As you can see, you now have the component floating in space. With components, you can simply grab them and drag them around anywhere you like, up or down. Since this is the base plate and from which our drivetrain will be built, it would be bad if we can move it around. To prevent this, we're going to ground it in place, meaning that it cannot be moved unless you unground it. To do this, right-click on the component here and simply select Ground. Now, no matter how hard I try, I cannot move this extrusion around. The next important step is to create the two side rails coming off from the drivetrain. And the way we're going to make this drivetrain is we're only going to CAD one half of the drivetrain and mirror it onto the other side. This will save you a lot of time and unnecessary headache. So to do this, simply import the next file, which is a 420 millimeter extrusion, and rotate it so that it's perpendicular with your existing bar. Its location does not matter too much yet, since we are going to be grounding it later on. Now that it's imported and in the correct orientation, we're going to link these two extrusions together with a rigid joint. Joints connect these two parts together and mean that when one part moves, everything moves with it. To do this, simply select the face on the extrusion, as you can see here, and select the face on the locked extrusion where everything will be built. It's easiest to select a face that is in the center of the extrusion, so there's one less area to calibrate later on. I like to select this face since it runs right through the center of the extrusion. Make sure you are holding Shift when you select the faces so that both are selected at the same time. Next, simply come to Assemble and Joint, and as you can see, they will by default snap together. Now, you can drag this extrusion to the end right here and to lock it in place. And make sure they're contacting like this. You can play around with the values if you need to. Before you save your joint, come to motion and make sure it's set on rigid joint. If you preview the joint motion, you should see they're rigidly locked together and should not move. Once that is done, simply press OK. So you've now created a rigid joint. What this means is that if you unground your base extrusion and move it around, the two components will move together. And just reground that extrusion. Okay, the next step is to create, we need to add one more side rail in over here so that the wheels are supported as well on both sides. So it's the same procedure as last time. Insert the extrusion, rotate it to the correct angle, drag it out. Location doesn't matter for now. Next is we need to select both the faces to create the joint. Again, remember, select the face in the middle of the extrusion, assemble, and joint. Not sure what's happened here, but I can just cancel it and try it again. I selected the incorrect face. So come down here, select the face of the extrusion, and make sure to select the correct face on your drivetrain design. You can see it's done correctly this time and it's been snapped in place. So we're just going to move it over until you have a Y offset of 95 millimeters. Now, make sure as well that the two parts aren't inside each other, so just drag it out to prevent that, so they're just touching. You now have two guide rails and a base piece on your drivetrain. The last element on this half is a brace to connect the two rails at the front. To do this, we need to know the exact size that it should be. So we're going to learn about the inspection tool. To use it, simply click Measure on the top of your screen. And now what this allows you to do is find distances and areas on your design. To use it, simply click a line on the end of one of the guide rails. As you can see, it shows you its length. Hold Shift and click on another rail, click on the other end of the other rail. As you can see, it gives you the distance between them of 124 millimeters. We now know what length the extrusion needs to be, so we can create a custom length. To do this, simply come back to your toolbar, click on any one of the extrusions you've imported, and now we're going to modify it to create our custom length of 124 millimeters. To do this, simply click on the face of the extrusion and come to create and use the extrude tool. We want to make this 124 millimeters long. But simply typing in negative 124 won't help us, since that's not the length of the piece we need to create. We're just cutting out of the existing extrusion. To remedy this, come over to the Extrude tab and Operation and change the tool from Cut to Intersect. So now the only part that will be saved is the intersection of your extrusion and the existing component, which is exactly 124 millimeters long, which we can verify with the measure tool, length 124 millimeters. Now that this is done, you need to save the file. Go to File, Save As, and it's important to label it so you know what it is. So save the file in your folder and come back to your drivetrain. Now it's same as with all of the other extrusions. You need to import into your current design and make sure it's at the correct orientation. This time, we're going to rotate it this way and move it closer to the two guide rails. Now, we're going to attach this extrusion here to the two guide rails, and everything should be locked together. So it's the same as before, except this time we're going to select the face in the center of the extrusion first, and the face of the guide rails second. And it doesn't matter which guide rail you choose to create the joint with, they will all still be locked together. Come to assemble and joint. As you can see, it's very similar to the other side, so you just need to move it out and move it across. And okay. So you've completed one half of your drivetrain. To complete the other half is very simple. Now you don't have to import all the files again and do all the measuring again. You can simply use the measure tool, the mirror tool. To do this, come to create and mirror. Once here, click on the component, make sure the type is selected as components. Click on the component you want to mirror, and the plane should be the y-axis. That's why it was so important to ensure that your first extrusion is centered on the y-axis. Once you've done that, you can see it creates a new component mirrored exactly the same distance as the original from the y-axis. Unfortunately, once components are mirrored, the joints are not saved with them. So you need to create all the joints again in the same way. So come over, select the face, select the second face, and assemble a new joint. Make sure to select both faces properly. There we go. Move it all the way across. And make sure that the extrusions are not intersecting. Now all that's left to do is to do the exact same thing with your two other extrusions. And that is it. You have just CADed the frame of your drivetrain. Everything has joints, everything is grounded together, and if one thing moves, the entire drivetrain goes with it. That is all for today. Next time, we will be adding in the wheels and the bearings. See you then.